Hi everybody. Today we will be looking at a Criterion B investigation. So when I'm referring to the Criterion B investigation, we're looking at more specifically the MYP Maths assessment. So generally the MYP obviously is made up of 4 different criteria, and each criterion will be assessed in most of the MYP schools. So today we'll be looking at one Criterion B investigation. This was taken from the eAssessment. I believe was the not was it the 2019 or the 2020 eAssessment. And usually this would be like the last question for each of the eAssessment papers. So today I just want to spend a bit of time to look at an investigation and how I would approach a Criterion B assessment or an investigation, and probably this might give you a little insight into some of the little tricks I would probably use, some of the command terms that you have to be aware of. So let's get down into business, okay? So if we look at this problem, it says that you will be investigating the size and the perimeters of the trapeziums, okay? In general, the skills that you need to unlock some of the puzzles in Criterion B investigation generally are quite easy. Some of the maths that you have to use is probably related to things like trigonometry. It could be a quadratic function, or it could be any skills that you probably would have learned in middle school and probably in high school as well. Okay, so let's look at this problem. It says that in part A it's worth 3 marks, and just for your information, Criterion B investigations are usually worth like 30 marks in the eAssessment. Okay, about there. Now, so if we look at this, it says show that the diagonal of the trapezium is 5 units, and we have the diagram that's drawn for us, and all we need to do is to find out how the diagonal is actually 5 units, and we have to show it. So we do know that if I draw an imaginary line here, we know that this obviously gives me 4 units. I do know that the if this is 1 unit, this has to be 3 units, because the total length of the base of the trapezium is 4 units. So, and this obviously looks like a right angle triangle to me, and of course I could use the Pythagoras to find what is the length of the diagonal. Okay, so I'll just call the diagonal to be D, and we know that the formula for the Pythagoras theorem is a squared plus b squared equal to c squared, and D obviously is the hypotenuse, so we have 4 squared plus 3 squared equal to 5 squared. So 16 plus 9 gives me equal to sorry, this should be C. We'll probably have to change this. C, oops, this will be C squared, and 25 equal to C squared. So C will be the square root of 25, which is 5 units. So therefore the diagonal is going to be 5 units long. Okay, so this is pretty clear cut. Alright, let's move on to part B. It says write down the missing values in the table up to row 6. The questions are interconnected. Okay, so it is obvious that if we look at the pattern in the table, it says that in stage 1 the side length is going to be 1 unit long. Stage 2, the side length, so which we are looking specifically for this length. If it's stage 2, it will be a length of 4 units, and it's quite pretty obvious that the pattern is obviously just going up by 3 each time. Okay, so it says describe, okay, in one word, so you have to write it in words as well. One of the patterns that you see for side S, and we know that one pattern is the side length. The side increases by 3 units as the stage number goes up by 1 each time. Okay. There are many alternatives to the answer. You could say that the side length goes in an arithmetic progression, but I still think it's probably better to give a more detailed answer about how much the length has gone up, which is obviously by 3 units. So that's one pattern that you probably would, the most obvious pattern that you would see, that's probably worth just a mark, and it should be an easy question as well. That will be 8C. Sorry, for 8B, we should fill in the table as well. So if it's adding 3 each time, this is going to be 13 and this is going to be 16 here. Very straightforward. And I would say that's an easy 5 marks so far. Okay, question 8D, it says determine a general rule for S in terms of N. So just again going back to the table here. All right, let me just kind of zoom in here. So we do know that the side length obviously is going up by 1, 4, 7, 10, 13, and 16, and we know that the pattern is always going up by 3 each time. So we do know that this is obviously an arithmetic sequence. Some of you may have learned how to find the formula of a general term in an arithmetic sequence. You obviously could use the formula. There are many ways to go about finding the formula for this. For those who are very keen on using the formula, it will look something like this. Okay, where you take the first term plus n, which is the specific term, the n term. All right, so we're looking at, maybe if we're looking at the m term, it could be like the 200th term, the 500th term, but it doesn't really matter. We're trying to generalize our findings here. So we're just going to call this n for now. And D would just be the common difference, which is the difference between the numbers in the sequence, which in this case would be 3. Now U1 is going to be the first term, and D is just the common difference. So this formula obviously works very well. If you see an arithmetic sequence, that should be a pretty obvious way to find a general rule for this. Okay, and I'm just going to go straight to finding the general rule. All right, so we could say that the general rule for S is going to be U1 plus n minus 1 times D. And I'm going to look at the first term, which is basically just 1 plus n minus 1 multiplied by 3. Okay, and I just have to do a bit of my expansion, and I should be able to get the answer. So I'll take n times 3, and I'll take negative 1 times 3 as well. So I'm going to get 3n minus 3. So I'm going to get 3n minus 2 for this. Okay, another way to look at this problem, if you are not very keen in remembering the formula, one way to look about this is that if we know that the common difference is 3, subconsciously you'll be thinking that the formula should start off with like 3n. But the only issue with 3n is that if you put n to be 1, so if I take 3 times 1, the first term is going to give me 3. If I put n to be 2, which is the second term, 3 times 2, that's going to give me 6. And if I keep following the sequence, I'm going to get a sequence that goes in multiples of 3. Okay, now technically there's nothing wrong with this, and all you need to do is just compare this to the original sequence, and you realize that each of these numbers, this sequence is always 2 more than the original sequence. So that's why the formula could just end up being 3n minus 2. That's another way to look at how the general rule is obtained here without trying to remember the formula in this case. Okay, so there we go. We got our general rule for S for question 8D. Again, we're going to move on to question 8E that says verify. Now, when you verify your general rule, you're basically trying to provide evidence, okay? But when you provide evidence to show that the general rule actually works, you would like to do something that is beyond what is given to you. Now, in the table that's given to you, stage 1, 2, 3, 4 has been given to you. 5 and 6 technically has not been given to you because you were supposed to find what the side length would be when it comes to stage 5 and 6. So it is technically fine to use stage 5 and 6 to verify your general rule in this case. Okay, so I'm going to use stage 5. All right, so when it comes to verification, all right, please use values which are not given to you in the table. Okay, now it makes absolutely no sense for anyone to do stage 100, because I'll show you why in a bit. Okay, now because technically you could find out what is the site length for stage 100, but it will not make any sense, because verification also basically means that besides provide evidence, you will need to show 2 ways that the general rule actually works. Okay, so one would have to be with the general rule, but that would not be good enough, because it's like maybe it could be by chance that you got the general rule right, the number seems to match, but how can we be certain that this general rule is actually the correct one? So it will always be good to have another method to show that this general rule works, and another method could usually be used in the form of a diagram that has been given to you. Okay, so I'll show it how this works with this question. Okay, now so we have the formula, which is s equal to 3n minus 2. So I'm going to choose when n equal to 5. The site length is going to be 3 times 5 minus 2 equal to 13. Okay, but how do we know that 13 is actually the correct length? All right, is it just because we saw the pattern? But how do we know if the pattern is right in the first place? So technically what I like to do is I like to go back to the original diagram. Okay, because all they basically said that is that the site, okay, sorry, I'm just gonna come to this again, is that the site length would change, but this length is not going to be changed. Okay, so what I'm going to do is I'm going to draw a diagram. Okay, so I'll draw a trapezium here. Remember, our objective is to find out what is the site length for this. Okay, since it wasn't about the diagonal, then maybe I couldn't make this even much easier for ourselves in this case. Then we don't really even have to do a diagram. We could just use the table. Okay, so I'm just going to add on some information here. Another method, which is the diagram given, or we could use the table that's given to us as well. So what I'll do is from the table, we know that we are always adding 3 each time, isn't it? So we know that to get to stage 5, we are always adding 3 to the previous stage. All right, so what I could do is since in stage 4 the number of sides, the site length is 10, and since the site length is always increasing by 3, therefore the length in stage 5 will be 10 plus 3 equal to 13. Okay, so since this number and this number matches, so since both methods conclude that S is 13 when N is 5, therefore my rule is verified. It's always good to give a concluding statement after you have shown how to verify the general rule. So let me just try to summarize this again. Remember guys, when it comes to verification, you always need to show two ways, okay, if you want to get maximum points for this kind of questions. So obviously one is you need to prove it with the general rule, but that would not be good enough to get you the maximum points. You would have to show it with a different way, and usually it comes in the form of a diagram, or it could be using the table. This is quite an elementary question. It's probably the next question that you probably would have to use a diagram to help to verify the general rule. Okay, so that will give you like 3 marks. I believe if you look at the mark scheme for from the eAssessment, it says that if you only use the general rule to verify it, you're not going to get maximum points for this question. Okay, let's go down to 8F. This is the meaty one that's worth 20 marks. Obviously we're just trying to put trapeziums together from stage 1 to stage 4, and of course in many other stages that comes after 4 as well. In the eAssessment, what usually does is that you will have an opportunity to investigate a similar pattern for the final meaty part of the for this criterion B section as well. So it says investigate the values in the table to find a relationship of the perimeter of the trapezium in terms of n. It says that you need to predict more values, describe in words, write down the general rule, test your general rule, verify, justify, and basically you got to do the whole thing pretty much on your own, and that's why it's worth 20 marks in this case. Okay, so what we'll do now is we'll just look at how we could find the perimeter. Okay, for stage 1, 2, 3, and 4 first, before we try to see a pattern. Then we'll try to come up with a pattern as well as writing a general rule for this. Now, so for stage 1, the perimeter is obviously just adding the 4 numbers. So that should give me 14 if you add up these 4 numbers here. Now in stage 2, again, you would just basically add up this number here, 4, you add up this number 4, you add up this 5, and you add up this 7. So pretty straightforward, you're just adding the 4 sides of the trapezium in each of the stage as well. Now the only thing that you probably would have realized that is the when it comes to stage 1, I'll just use a different color here. Probably red is not a good idea. Just probably use yellow. Okay, if you realize that this length and this length in stage 1, 2, and even stage 3 and so on, they always have the same length. Even the diagonal for each of the stages have the same length as well. So the only variable that changes from stage 1 and so on is this number here. Okay, it's this number, which is 1, 4, 7, and 10, which is basically the same pattern that we have seen earlier, which goes up in an arithmetic sequence here. And so I think it looks quite straightforward. So let's try to go in stage 5. Let's look at what's the side, and let's look at what's the perimeter for this. So obviously this is just going to be 13 and 16, which is very similar to what we have done earlier. And the perimeter here is just basically adding 6 each time. Okay, then we're going to add 6, and we're going to add 6 here, which is 38 and 44. And of course we could always find the perimeter by just adding up the 4 sides again, since we have all the sides of the trapezium for each of the stages as well. Okay, so we record this in the table, so this is done. So it says describe in words a pattern for column P. So a pattern would be the perimeter P follows an arithmetic sequence as well. The perimeter goes up by 6 each time. As the stage number goes up by 1. Okay, so that would be straightforward. I'm just going to call this part 2, this part 2 as well. And the next part, in part 3, it says write down a general rule for P in terms of N. Very repetitive, very much the same thing again. So what I'll do is, again, since we know that it's always going up by 6, so I usually like to start off the formula by doing 6n. Okay, again, this trick always works. But if we do 6n, we know that this always follows a sequence that goes in multiples of 6. Okay, but the original sequence, all right, was meant to be 14, 20, 26, 32, 38. Okay, and again, if you look at this sequence that comes with 6n, and this was the original sequence, we know that we have to add 8, okay, in order for us to get 14, 26, all right, because the difference between these numbers here is actually 8. So 6n plus 8 is going to work for the general rule here. Now that brings us to part 4. It says test your general rule. Okay, so testing the general rule for this, again, the difference between testing and verifying is that when it comes to testing a general rule, you must use those numbers that's given to you in the table. Okay, test, use values in the table. So that's the subtle difference between testing and verifying. All right, verifying, you use values that's not given to you, while testing, you should be using those numbers given to you in the table. All right, so what I'm going to do is you have a choice between from 1 to 4 because these are given to you. So I'm going to try when n is 2. Okay, just 1 is good enough. So p would be equal to 6 times 2 plus 8. That gives me 20. All right, which obviously matches with the perimeter here. Okay, so this is done as well. All right, part 4. All right, let's look at part 5. Okay, so it says verify and justify your general rule for p, which is the final bit for this one. Okay, so let's do the verification first again. Again, very repetitive, very similar to what we have done earlier. I'll probably do when n is 5. Okay, because that's the one that's not given to us. We found those values on our own, but we have to go verify it. We need to provide evidence for this. So when n equal to 5, all right, we do know that the perimeter is equal to 6 times 5 plus 8. That will give me 38. Now, I want to show you another way to verify the general rule, not just by using the table, because there is obviously this is all about combining trapeziums together. Now, I know that in stage 5, what I'll do is I will just add another trapezium here, okay? And I know the trapezium is going to look something like that. Now, this is going to be 5, this is going to be 4, then this is going to give me 13, okay, and obviously this is going to give me 16 here. Okay, now, so if I want to verify this, okay, and I found out that the perimeter when n equal to 5 is 38. Now what I would do is stage 5 is that since I have all these numbers here, all I need to do is just go find out from the diagram. All right, so you need to draw stage 5, all right? It is crucial for you to draw stage 5 to show that the perimeter is indeed 38. And you need to show that why is it 13, why is it 16, what is it 4, what is it 5. So you have to draw that trapezium on your own, okay? So from the diagram in stage 5, I'm going to call it S5, the perimeter is going to be just 13 plus 4 plus 16 plus 5. Okay, and when you add all these numbers up, you should get 38 as well, and that's where you verify the rule. So rule is verified. Okay, so you see where I'm coming from. You could use the table, you could use the diagram. That's what I'm saying. And when it comes to verification, that will give you the maximum score for that. Okay, now the final bit, we're going to look at justifying the general rule. Okay, and let's look back at the diagram here. Now, we do know that the formula was 6n plus 8, but that's based on what we have seen from the number sequence here. Now, when it comes to justifying the general rule, what it really means that you're supposed to provide an explanation on how this rule came about, but with a slight caveat in this case, is that it must relate to the context of the problem that is given to you Okay, so if you were basically just saying that, oh, I got 6n plus 8 as my formula or as my general rule, is because it follows an arithmetic sequence. So you're basically repeating what you have just said earlier in part 3. Now, that's not going to give you the maximum score. What you want to do when it comes to justification is to go back to the diagram and think about how we can actually find the general rule by using the diagram that's given to us. So going back to the diagram again, we realized that the main pattern was these two sequences, these two numbers are the ones that's always going to be changing because it follows an arithmetic sequence. This number is always going to be 4. The sides of the of this trapezium, which is always going to be 4, and the diagonal is always going to be 5. Okay, so what we're going to do now is we will go find out what this formula is. So let me just draw a trapezium here, okay, by using the diagram. Now we know that this is always going to be 4, this is always going to be 5. Now we do know that the top part, which is actually the S, which is the side, we basically know from the previous part that the formula was 3n minus 2. So I can actually write that this is 3n minus 2 here. You could say that 3n minus 2 was obtained from the previous part of this investigation. Now, and you would have realized that the bottom part of this side is always going to be 3 more than the top side. Okay, if you don't trust me, let's look at this stage 2 here. Okay, if we look at this trapezium here, if this is 4, then this would be 7, which means that the bottom part is always going to be 3 more than this. So we know that if this is 3n minus 2 at the top, then this would be 3n minus 2 plus 3, which is going to give me 3n plus 1. Okay, so what I would do now is I would simply just add up these terms together, because that's going to give me the perimeter. So the perimeter is going to be just give me 3n minus 2 plus 4 plus 5 plus 3n plus 1. So when I add everything up together, 3n plus 3n is 6n, negative 2 plus 4 is 2, 2 plus 5 is 7, 7 plus 1 is 8. There we go, we got ourselves 6n plus 8, which is the general rule that we found out in part 3. Alright, and it's basically using the diagram, which is the context given to us, to help us nail this general rule. I hope this pretty much explains what a Criterion B investigation generally would look like, and what it means by verifying, what it means by testing, and what it means by justifying the general rule. Okay, well, it's an easy investigation. I'll probably would do more videos in the near future on more Criterion B investigations. There's one that I'm going to make soon, something that looks a bit harder, and just please stay tuned as well. So if you like this video, please hit the like button. Alright, and I'll see you guys very, very soon. Alright, till next time, and have a great day, guys.